and I run the day-to-day operations and development of the AppCenter product. I want to be the first to welcome you here. Thank you for coming, and it's going to be a good day, long day, full of pretty in-depth technical discussion of what Application Center is, how it's put together, what it does, and what's possible with it. And what's possible with it really leads into why you're here. As ISVs, OEMs, partners, authors, you're in a unique opportunity to help us add value onto Application Center so that when we launch, when we deploy the product out to customers, your products, your infrastructure, your books, your OEM products, etc., are there supporting the product, adding value to the product, and helping the product fit into the infrastructure that people have already built on the work that you guys have done. So for those reasons, I thank you. I thank you for being part of the extended product team. I sort of feel as though I feel about you that way, as though you're part of the product team. You'll be hearing from some of the best people on my development team about the product all day long. It's a lot of content today, so without any further ado, I'm going to turn this over to Garth. So thank you for coming.
Thank you, Quentin. So we're done with that. A couple things. My name is Garth Ford. I'm the lead product manager on AppCenter. My primary role today was to fund the event, pay for it, and get you guys here. I'm going to do a little bit of housekeeping at the beginning. We're going to go through that stuff. We're going to spend the next hour focusing on just sort of introductory stuff, sort of what the product is, design goals, etc. Bob's going to come up and do a quick demo. And then we're going to save time at the end of this hour for about 10 minutes of Q&A. After that, we're going to go deep into the technical details. So any questions and answers you guys have about just sort of the general day, the overview, timing and schedule, etc., let's deal with that at about 9:45. So a couple notes on housekeeping. Want to go through sort of what are the goals for today, like who's here, why you're here, etc. Want to talk about what we're going to be doing for the rest of the day, and I'm going to pull up an agenda. I think you guys, did everybody receive an agenda in email? Okay, good. So none of this should be news. I just want to give you a little bit more detail on what we're talking about. A couple notes on security. That's not a big deal. And then I want to give you the name of some key contacts while you're on campus today. If you have issues, I'm going to give you my cell phone so you can call me if you need me. So the goals for this event were to brief what we consider the key engineering partners. Everybody in this room is an engineer. You guys do work. You have your own product schedules, etc. Whether you ship servers or whether you write software or write books, you guys need some lead time. So the goal here is to give you guys the first public look at what we have for the product. So we want to introduce you guys to the product team. Quentin just did the kickoff. We really do feel like we want to have a really good partnership with you. So make sure that you follow up with us directly. You should all have my email. So if you have questions about who to talk to or you have questions, feel free to come through me, and I can triage as appropriate and get it to the product team. A specific non-goal of today, we're not going to be talking about any business development, any co-marketing opportunities, anything like that. We're going to have opportunities later in May or as closer we get to RTMing to actually talk about sort of the business side of things. So today is supposed to be primarily focused on face-to-face time with the engineers, talking about the actual bits. And then, of course, we want to do lots of Q&A. So we got a big room, but the acoustics are pretty good. So you guys, if you just want to, raise your hand, ask questions and stuff, we're going to be able to answer those. We want to spend a lot of time just like mingling with you guys and dealing with your individual questions. Just a note, we are videotaping this thing. So we're going to ask that you hold all questions for each presentation until the very end. So we can have the program managers get up, run through their deck. You guys should have room on your handouts for notes. But save those questions to the end for the last 10 minutes, and then we want to make sure that we get those on tape. So basically, the way we started, 8 to 9, we're done with. You guys had your munchies. We're going to have food throughout the day, so don't worry about that. If you want to bring food in here, feel free to wander out, grab a drink, bring it back, whatever you need. The introduction, I'm going to be covering that. Basically, this next hour, you guys ever go to see like a comedy show, like you buy a ticket to Robin Williams, and there's an opening act, right? They make you watch Carrot Top for an hour. Okay, so I'm Carrot Top. So I'm supposed to warm you guys up, so to give you an overview, get you hyped while the caffeine soaks into your system. And by the time I'm done, the product team's asked me to leave because they don't think marketing adds any value. So I'm going to leave at the end of my presentation, and I'm not going to see you guys again until 6 o'clock. So if you have questions about sort of any business or marketing stuff, feel free to hold those until 6 o'clock when you'll see me again. Martin Sleeman's going to start off. We're going to have 3 really deep, in-depth presentations. Sorry? Okay, well, my agenda maybe is a little bit out of sync, but we're going to start off. We're going to have 3 basic presentations. Martin Sleeman Alex Sutton and Ori Amiga are going to get up and give you like really, really detailed sort of decks on their core feature areas. At the end of that, at 4:30, we're going to have some product managers in here from some of the other product teams. We've got a bunch of products that are shipping in the next calendar year. We want to make sure that you guys sort of understand the timing and the schedules and other things like that. They're going to be available at 6 to 9 for Q&A. We're going to have guys from the SQL Server team, the Commerce Server 2000 team, the BizTalk server team, and then the Host Integration server team. They're all going to be here for Q&A at the end of the day and then for the roundtable during the dinner event. So dinner is going to be in this building from 6 to 9. We're going to be co-mingling with another group. Some of you may be here primarily for the Windows 64-bit design review, which is happening tomorrow. But everybody who's coming to that event and everybody who's coming to this event are going to be mingling today from 6 to 9, and then we'll do Q&A with the product team. Any questions on the agenda? Wonderful. So just a note on security. This is an NDA event. Everybody's gone through the gauntlet at the front. We know we've got NDAs on file. I just want to reiterate that. From a marketing perspective, I'm very, very comfortable telling you guys everything, and the product team has been authorized to tell you, answer any questions that you possibly have. We haven't started talking to the public about this, so the slides that you have are pretty sensitive. It's a 1.0 product, and so what we're telling you today is the plan of record, and this is what we plan on doing. But being a 1.0 product, you guys know how software works. We will cut features in order to hit ship dates, and so we don't want to commit publicly to any features that may end up getting cut. You guys are pretty sophisticated. You understand how that works. But for like members of the press, the audience, or the general sort of customer base, we don't want the slides that you guys have getting into their hands and getting them excited about a feature that may end up being cut from the final product. So that's just a note on that. We have hard copy of the slides today. When we get done in a couple weeks, we're going to end up scrubbing the slides, taking your feedback and your questions, and putting that back into the decks, and we want to send that to you. Also, we don't have alpha code yet. We were hoping to be able to distribute that today. We weren't able to get like the daily builds in a state where we thought you guys would actually be productive evaluating the product. So as soon as that's ready, we're going to send you like a follow-up packet that contains the electronic slides along with alpha version of the code. So the event's going to be videotaped. I apologize. Some of you I know have got very, very short notice. This event was originally intended for about 15 people, and we opened up the scope only about 3 weeks ago. So some of you may have only gotten invites, say, last week. So I apologize for the short notice of that. For those of you who couldn't make it, if there are members of your staffs who couldn't come, we're going to make the videotapes available as part of that follow-up packet that we send in a couple weeks. So again, apologies for the short notice on the event, but nobody's going to miss anything critical that they can't view later. So key contacts, I'm going to have my cell phone with me all day. Feel free to write this down. Give me a holler if you have any questions. I'm going to be in and out of the event all day. The people out front who are helping us out, Ann Muzzy at the front, I think everybody met Ann? Okay, she was the one who sent you your invite, got your NDAs, et cetera. Questions about general logistics, she can help you out. Bob Pulliam is going to come up and do a demo for us. He's a product manager. He'll be around most of the day. He can help you out if you have questions about marketing or PowerPoints or any of the demos that you see today. Reed Gerson is out front, also helping with the registration. He's actually in charge of your handouts. So we have plenty of extra copies. If you want to take a couple extra copies of the handouts home and share with your staff, that's fine. He's just going to need to go grab some from his car. So anyway, that's Reed. He's the guy who is in charge of handouts. So any questions about housekeeping? Everybody good? Okay, good. So this is the Garth Fort does the carrot top thing. So for the next 30 minutes, I want to sort of set the context for AppCenter, tell you sort of the design goals, the history of the product, why we're building it, et cetera. I'm not going to be getting into deep technical information. We're going to save that for the experts who know how to do that better. But that's what I'm going to do for the next 30 minutes. And so Windows DNA 2000. How many people have heard of Windows DNA 2000? A few of you guys? Okay. It's been kind of it's a marketecture type term. We've abused it. It means a lot of different things to a lot of different people, which means it's sort of worthless from a technical standpoint. Over the next 9 to 12 months, we're going to be talking about Windows DNA 2000 a little bit more concretely as the set of products that Microsoft offers for building web applications. Our product strategy doesn't quite fit into a nice clean niche like EAI or application server. We have a bunch of products. We think they're designed to work together and they fit a lot of the core scenarios that we're going after. But this is the only way we have of talking about our cross-product scenarios. So the heart of this is really Windows 2000, which shipped on the 17th. I'll spend a little bit of time talking about that. And then we have these extra servers that run on top of Windows 2000, all of which will be shipping first or new versions in the next 9 months. In terms of like Microsoft terminology, there's a little clue here. If it's something called a service, it's included in the operating system. If it has an R on the end and it's called a server, we charge you extra for it. So if you get confused about the terminology, that'll help you out. So we talk about the core application services in Windows 2000, and this is the plumbing. This is the stuff you saw first as NT Option Pack in December of '97. It's now been updated and refreshed in Windows 2000. Every single piece has gotten individually better. The integration between the components has gotten better. The management infrastructure is now common across them, et cetera. We specifically refer to 4 main services and sort of sub-features there as these application services. The first is Internet Information Server, which includes active server pages. We also refer to COM Plus now. And COM Plus is the term in the documentation and the product literature, which is now used as an umbrella to cover the acronyms formerly known as MTS, DCOM, and COM. So COM Plus is really all of the component-oriented stuff built into the operating system, much tighter integrated with the underlying kernel. So that includes the component model itself, new support for something called object pooling. There's support for automatic transactions, just like you had in MTS. There's queued components. This allows you to take a component and declaratively enable method calls to be routed through an MSMQ queue. So that's pretty cool. And then we have role-based security. This is one of the top requests of MTS. Users were having to architect their applications backwards so that they were designing components in accordance to their security policies. In COM Plus, you can now apply security on a per method level. And so you have much more granular control over access to your methods and your components, which means you can architect the apps you want to architect in the correct way and then apply the security later. Microsoft Message Queue version 2.0 is shipped. This is a fit and finish release. We've done a lot of work in making sure that the core functionality is much more stable. We've also now support MMC for the management. It's much more tightly integrated with the rest of the services as well. We also talk about universal data access. This is the Microsoft Data Access components. So the centerpiece of this is ADO 2.5, which now has support for XML, and then sort of all the attendant OLADB and ODBC services that come with that. And then finally, there's network load balancing. This really isn't a service in the, from the standpoint that developers need to program to the API, but it's included in Windows 2000 Advanced Server and does the HTTP load balancing, and you'll hear a lot about that. This is the context for Application Center 2000. Just to make sure. So what we are focusing on users who are building applications to these core set of services. These are web applications and component-based applications. That means specifically, we don't care about the database tier, right? If you're building server-based applications that don't use these services, we're kind of irrelevant for you. We found customers were having an enormous amount of pain trying to scale and manage farms of farms of servers that were running applications written to these services. And so that's where Application Center 1.0 is focusing. So we don't worry about the networking layer. We don't worry about the database tier. For example, like SAP R3, we're oblivious to it. And so it's just applications that fit the specific architecture written to the Windows DNA application services. Any questions on that? Great. Hopefully none of that was news. So Windows 2000, I want to do just a couple minutes. The main feedback we've gotten from customers is that the reason they don't like using NT or are hesitant to use it for mission-critical applications are, number one, reliability, and number two, scalability. And so Windows 2000 is a great release that is designed to address a lot of those core features. Application Center is going to enable people to make it much easier for you to build out scaled-out clusters of Windows 2000 servers, and we think that's going to help both the scalability and the reliability issues. So just a note about uptime. There's a stress test that Ziff Davis Labs runs, and this is just like the most brutal stress test you can ever run on a client. And they've run it on Windows 95 and NT Workstation, and this is the mean time to failure. And this is really a reflection of the stability of the kernel. It's actually fairly easy to crash Windows 95 and relatively easy to crash NT Workstation. But what in essence it means is that after 5.2 days with NT Workstation 4.0, the kernel becomes, or kernel level services become corrupted and they need to restart the machine. When we released Windows 2000 to the world, or at least to the manufacturers, we gave it to ZD Labs. We asked them to run those same stress tests. Windows 2000 has basically never crashed. These are still running. As of 2.17, they were over 90 days, and the kernel has never had to be rebooted. A lot of this is about this specific benchmark measures stability of the client side of Windows 2000 Professional. but it's the same results we're seeing on customers on the server as well. All that work that's gone into protecting the kernel, things like system file protection and device driver signing, work equally well on the client and are having huge benefits on the server as well. So stability of the operating system alone is actually much better. And we talk about how to get scale. Microsoft has sort of two fundamental approaches to scalability, one of which we call hardware scale or scaling up. This is how the industry has thought about scalability for a long time. But it's about making a server that's bigger and bigger and bigger. And so Windows 2000 Server supports 4 symmetric multiprocessors, Advanced Server supports 8, and Data Center will ultimately support 32. And attendant larger memory, more gigabytes of RAM, bigger hard drive configurations, et cetera. So we really like this approach, and the operating system is working very, very hard with a lot of the hardware vendors to come up with the new buses that are required, the new advancements on the hardware level that are required for scaling up. And so we're going after this like full bore, and we have lots of teams at Microsoft who think about scaling up. The other approach is scaling out via these clusters of smaller servers. And this is where we primarily think about this stuff. Customers discovered this at the HTTP layer first, because it's a stateless protocol, and scaling out actually is uniquely fitted to the protocol of HTTP. And so, 5, 6 years ago, people building really big web apps discovered primitive ways to do scaling out via DNS round robining. Eventually, hardware vendors caught up. We got guys here from F5 and Cisco. Those guys understand this problem very, very well. And it works very well for certain parts of the system, specifically for the web tier and for the component tier. When you architect your applications appropriately, this is actually a very effective way to get massive scale and to get high reliability. There's some trade-offs, however. The hardware scale is fundamentally about bigger and bigger boxes. The software scale is enabled through software. And so services like network load balancing and then Application Center as a product is going to enable that. You can use standard high-volume hardware, in other words. You don't have to use any special hardware. The bigger boxes end up getting more expensive. So the cost of a 16-way system from Compaq that's running a Windows 2000 Data Center edition is going to be a lot more than the price of like a one-way Compaq times 16. So you have much more expensive costs where the scaling out approach is about using standard high-volume hardware. Costing increasing with scale. I just mentioned that costs of larger boxes actually look more like an exponential curve than they do linear. Where the software scale approach, it's a much more understandable economics. You can add a $2,000 box and know you get an extra 100 users or whatever your particular application supports. In terms of reliability and availability, we're trying to get much more precise about the way we talk about these two words. Reliability in the traditional jargon refers to mean time to failure. It's a metric that you can measure for an individual system or an individual component. And you're limited to that metric when you're talking about putting everything you have on one big box. We call this actually introduces what we call a single point of failure, right? And you're limited by the mean time to failure of any individual component on a single server. In this scaled out world, the metric that people are more concerned with is application availability, which refers to like, is my application running? Is it up and running? And in that sense, when you use this scale out approach, you actually have a nice little thing, a nice little equation where you can say the availability of the application is equal to 1 over the mean time to failure of an individual server raised to the power of the number of servers in the cluster. So while it's mathematically impossible to ever get 100% uptime, we do have customers who are using this scaled out approach who have never had that layer of their application fail. The URL always stays up and the components are always available. So this approach actually, measured at an application layer, is very effective. There's some trade-offs, though. When you're managing one big box, you can have like 2 people who do that in a shift basis, and that's really all you need to worry about. Managing these large clusters of servers actually becomes a little bit problematic, and there's some evidence that once you get over a certain critical point, management costs actually become exponential, which is quite a big issue that our customers are asking us to address. So I sort of summarized this stuff. We call this internally the attack of the tiny servers, right? And it's Microsoft and the OS guys and AppCenter and the hardware partners going after these big boxes because we fundamentally feel that for certain parts of an application, this is a superior approach. We have really good feedback from customers that they would prefer to do this approach, but we need to make it easier for them. So a couple interesting things. The scale-out approach doesn't just apply to the web and component layers. That's all we think about as the Application Center team. But the SQL team thinks about this as well, and they just released some new benchmarks that actually address, they take the database layer and they scale that out. using a new feature that's coming in SQL Server 2000. And to understand sort of the impact of this scale-out approach, I want to sort of talk briefly about TPC benchmarks. And this is something where Microsoft for a long time has always had to rely on price performance as a crutch, because we've never been able to play with the big boys. When you look at these TPC benchmarks, this is as of 2.16, the only two NT benchmarks that were in there were running Oracle databases on compact hardware, and frankly, they were 30% slower than the top end. So the previous world record TPC benchmark was an Oracle 8i database on IBM AIX RS6000, right? And it was about 136,000 transactions per minute. Well, when we released Windows 2000 and a new version of SQL Server, we went and we did a scale-out benchmark using SQL Server 2000. And this is sort of conclusive, audited, third-party validated proof that this scale-out approach actually works, and in a lot of cases is superior to the single scale-up approach. And so we released these benchmarks on 2.17. Again, these are fully audited. Don't believe me, go up to www.tpc.org to check them. But basically, we now hold the world record. And when we did this, the first version we did this was an 8-node scale-out approach with the database. And this is Windows 2000 as the operating system, native COM+ transactions as the TPM, and we're using SQL Server 2000, a beta version of the next version of SQL Server. And we first came in and we did this benchmark, and with 8 nodes, we got about 152,000 transactions per minute. So we were able to best the Oracle on RS6000 benchmark by quite a ways. And we brought the results back, and we actually showed the preliminary stuff, pre-audited stuff to Bill, and he said, why don't you scale it out further? And he wrote a check and gave us some money for some new hardware. And we went to our buddies at Compaq, and we picked up some new 8-ways, or I think it was 8-ways, and we brought 4 new things, and we redid the benchmark, and we're able to get just huge results. And we actually know how to do the scale out now in the database tier. And frankly, over the next year, the TPC numbers are going to begin to, they're going to start to look, frankly, ridiculous. At 230,000 transactions per minute, right, we were 60% faster than Oracle 8i on IBM AIX. And I think the metric was that at that rate, we could process every electronic commerce transaction for calendar year 99 in about 2 weeks. Right? So these numbers are huge, and frankly, there's nobody in the world who would ever be able to push this system to its capacity. But we now know how to do this, and we're going to be investing very, very hard in all of our server products so that they each have a scale-out component that works in this way. So we've also done some previous benchmarks, and I'm not bringing this up to harp on it. I want to talk about this slide because we learned some very painful things about the way our system works today. And so these were some benchmarks that were done. Ziff Davis Labs did a competitive application server shootout with our stuff against a lot of Unix, EJB, Java type application server vendors. The guys who did this were Doculab. They were paid by Ziff Davis, not us. But it was a very fair benchmark, and the benchmark's been published. You can download it. We're actually going to have soft copy of the report for you to read. You can take that home today. We'll make sure you get that at 6. The interesting thing about this was we were able to win, right? And that was good news. But the process of winning was actually very painful. And there were 2 things that came out here. First was that every vendor was given 12 weeks to implement this benchmark. And we were able, using Visual Basic and ASP, we hired a vendor from a third-party company to come in and help us implement this. And they were effectively done implementing the spec in about a week. Now, the remaining 11 weeks were the really painful part. And that's where we learned the most. The first 4 weeks after we got done, we actually had to hire a second expert to come in and help us set up what was then known as WLBS. And we had to set up MSCS on the database and WLBS on the web tier, et cetera. And it took us 2 full-time guys 4 weeks just to get the system up and running. And that kind of pain was interesting. It's the first time I, as a marketing guy, had a chance to see how painful this really was. And since then, I've gone out and we've been talking to customers, and I think it's exactly what the customers have been going through for the last for the last year and a half since WLBS has been available. The other interesting thing about this was that we were able to get the app up and running really quickly, so that's fine. But it was the tuning process that actually got us these results. So we spent 4 weeks actually configuring the system, just getting them up and running, and the remainder of the time just tweaking, stress testing the app, and tweaking. And in the process of that, we found 6 high-priority bugs in NT4 and NT option pack, which we had to fix with a service pack, and then we released that, or those fixes then got re-implemented in Windows 2000 Server. And so we found out, it was the first time anyone at the company had really tried to replicate, high availability environments that customers have figured out at large websites. And this was a great learning experience for us. And a lot of the learning here has gone directly into the AppCenter product vision. So just a quick note on economics. I spend a lot of time talking to CIOs about their underlying business issues. And there's an interesting trend that's emerged in conversations over the last year with these guys. What they say is that they want to, like, when they talk about scalability, a CIO really wants to be able to have, he just wants to be able to keep up with the traffic. Because they all track this metric, right? If they're involved in commerce, and most serious websites are, right? You know, their traffic is proportional to their revenue, right? And that's what they're interested in, you know, at the end of the day. And what they say is, and it was a CEO of a big web company who told us, like, I don't have a scalability problem with NT, I've got a manageability problem. And in a nutshell, after about an hour talking with him, he basically built this graph for us that said, the scale-out approach works really well because it's linear scalability and I can keep up with my traffic, which is really good, which means my revenues are growing. And the scale-out approach, or the scale-up, the big box, that's the blue line there, he doesn't like that one because, you know, he ends up having to pay enormous amounts of money for these systems which become a single point of failure. And if they fail, right, the whole site can go down. So he really likes the safety net of having 150 servers that are actually running his application, all of which are redundant, any of which can fail in a 24-hour period, but the site never goes down. The problem is that in terms of management, he's having to hire another human being at a fully burdened cost of over $110,000 a year every time he adds 10 new servers to the farm. The management costs have gotten exponential once you get over about 150 servers. And so at the end of it, he says, this is my revenue, right, which is proportional to my hits, which is exactly what my costs look like. And for him, that means he's got very flat margins. Right? He has zero margin growth as the site gets bigger and bigger, and that's not what he needs to show his stockholders. And so the whole goal of Application Center is really to drive down the cost of managing these farms. And we do this through, you can think of it as software or server consolidation through software. But the idea is instead of managing all these different components on 150 servers, we want you to be able to manage your application, right? And then add and remove hardware as necessary. Hardware becomes an afterthought. But you want to be able to manage, to do your change management, to do your monitoring, and you want to do that at the application layer as opposed to the individual component layer. And if we accomplish our goals, it won't be perfect in version 1.0, but it should be a lot like RAID, right? Which is total administrative transparency, right? Whether I have, you know, one disk in my cabinet or whether I have 20, right? From an administrative standpoint, there's no additional burden. And if one of those goes down, I just pull one out and I throw it away. But we want to take the idea of RAID, which is managing multiple subcomponents as one, and apply that to the entire server. And hopefully that's going to drive down management costs. And in our big sort of portfolio reference sites, we're going to drive down their costs and increase their margins. So that's at the end of the day what our compelling story is. So the common threads, I've touched on a lot of these, but these are the main issues that we're trying to address in AppCenter, is that first of all, it's actually difficult to manage applications. One of the issues that customers have said is that web applications are a different beast. They've got VB developers who know how to, like, you know, draw a form, double-click, write some code, you know, and then compile into an exe, which is something that's fundamentally more manageable. You can put it on a floppy, you can put it on a share, et cetera. These web applications tend to be very intimately tied to the underlying operating system. And so your files, your components, and your configuration data is kind of scattered. And there's no real way to manage that as an application. So that's one of the things we want to fix. It's also difficult to spread an application around an array. Like, the biggest barrier is actually going from an application which runs well on one machine to an application that runs well on two. And the hurdles involved in getting over that initial hump are huge. And frankly, in our usability tests, like about 80% of the people who try to do that end up failing. Once you get over that hump, though, adding the third, the fourth, the 10th, the 100th server actually becomes much easier. So we want to make it easy to do that. Adding another machine to the farm is a process that on NT4 with NT option pack and SP3 and SP6 and whatever was remarkably difficult. And in big farms, we end up finding utilities, like we have our own utility called SysPrep that a lot of the OEMs use, or you find Symantec's got a tool called Ghost. But what customers are having to do is basically image an entire hard drive once they get into their golden state. And, you know, instead of manually doing the labor, it takes about 6 hours on average to add a server to a farm. We want to make it much easier for somebody to do that, right? To run a wizard and just simply say, add another box, add another box, add another box. It's difficult to manage an application. We have a group of customers that we've been talking to since about June, same 10 customers over and over again. A lot of them are at our big reference sites that we have case studies for. And what they basically told us is that their main concern, right, is diagnostics. They know they've gotten their farms running, they're okay with it, but when something goes wrong, that's a big issue. And they get paged at the middle of the night, and they have to run in, and then they have scooters, right, that they run around the data center, and they try to touch all the machines, and they're looking at perfmon, and they have to figure out what is going wrong. And so one of the things we wanted to do is provide a central console where we're sucking in all the relevant performance data that you need for like diagnostics, just to know if your application is healthy, to bring that into one place. And it's not the whole thing. We don't monitor the database really well. We don't monitor other operating systems. We don't monitor the networking layer. But for just those servers in the farm, for the web and the component farm, we wanted to bring that data into one place so that you could analyze it to make sure everything was healthy. And then finally, testing applications is remarkably difficult. The process involved with writing it, getting a version of your application done and on a one machine, and then pushing it to a staging machine or to a separate private DMZ zone where you can test it off on the web, and then finally getting it into production. The whole process of doing that is remarkably painful and involves a lot of manual labor. So the two design goals, like at the heart of it, what we're trying to do here is Microsoft as a company, the hardware vendors overall, we're very excited about enabling scale out. And the first place we want to do it is at that web and the component tier. But in order to do that, we have to, one, reduce the barrier to entry, which makes it just make it easier for people to set up these clusters. And then two, we want to reduce the ongoing operational costs so that you don't have to keep hiring humans every time your server gets above a certain level, every time your farm grows beyond a certain scope. So our design goals is, we have some weird terminology. We're going to get it fixed in the final product, but we call these things reliable arrays of computers. Right? And that's to distinguish it from clustering, because we have some terminology issues that we need to fix with our customers. But we want to make managing these farms of redundant arrays of servers as easy as possible. And then we want to vastly simplify what is today a very onerous process of managing and deploying web applications built to our core OS services. An explicit non-goal for us is we didn't want to create any new APIs. So the platform SDK contains something like, at last count, a little bit over 37,000 APIs. And I've never met a single human being who knows every API in Windows. And likewise, I've never had a customer come to me and say, you know what, this stuff's just too simple. Please make it more complex for me to build these applications. And so when Quentin started on the project, right, one of the initial design goals for everybody, for all the program managers, the people who are designing it, is we have to make it possible for somebody who knows how to build an application and get it running on one box to scale that thing to a farm. And that means that there's no cluster-aware APIs. You don't have to write resource managers. It's not like Wolfpack where you have, for the failover. You guys are familiar with that. We just basically wanted to say, if you can pick up a copy of VB and write an ASP application, right, to ASP and COM+, right, we can make that thing scale for you. And that's a little bit disingenuous. Of course, we do have APIs that you're going to be hearing about today for guys like you, right, for management vendors, for people who want to script it, for people who want to integrate with it and suck our data out and integrate it with other consoles. We do have APIs there, but not for the developers who are writing the core applications. Is that clear? So it's not a new platform. We get a lot of questions about how do I write an Application Center ready application today. And the bottom line is if you can get it running on a Windows 2000 server using those core application services I mentioned, that's an Application Center ready application. We're going to be able to take it and scale it. So some terminology. So a cluster. OK, you guys can read the slide, right? The bottom line is our terminology is kind of messed up, right? VMS clustering set the bar. Microsoft released something called failover, aka Wolfpack, and we called that Microsoft Clustering Service. But it wasn't what customers were used to. So the term clustering was originally, in the VMS world, meant a bunch of servers working together on a common problem, right? And when you grouped a bunch of them together, you basically got two benefits. In the VMS world, you got both scalability, right? Your throughput increased, and you also got failover. So if one of those machines failed, the other picked up the slack. Well, Microsoft's first stab at clustering was failover. And as you added one machine or a second machine using Wolfpack or MSCS, all you got was failover, and you didn't get any increase in capacity. And so over time, we've added two new technologies here to this. So the first is network load balancing, which ships in Windows 2000 Advanced Server. It was a company called Valence Research, and they were out of Portland, and we bought their product called Convoy, released it as WLBS for NT Server 4.0. And then decided to change the name in Windows 2000. So it's now called Network Load Balancing, but it's the Convoy stuff if you're familiar with that. And this basically just sprays a bunch of HTTP requests across a group of servers. The other piece is you need to be able to balance the execution of components across a group of component servers or application servers. This is something called component load balancing, which originally previewed in an early RC candidate for Windows 2000 Server. It was eventually removed from that product and is going to see its final commercial incarnation as part of Application Center 2000. There's a tech preview available today if you guys want to see it. You can send mail to clb@microsoft.com, and you can get a hold of the bits and start playing with it to understand it. When you get the pre-release version of AppCenter in a couple weeks, we'll have it in there. So, but if you're really hot in the next 2 weeks, you can go get the tech preview now. But that, again, is balancing execution of complex components across multiple servers. And then finally, there is what we call the formal Microsoft Cluster Service, which provides just failover. And this is most applicable at the file level for Exchange and for SQL Server. So that's sort of a mea culpa. I apologize for the confusion about the terminology. We're going to be straightening it out over the next 2 years. But that should clear things up for the rest of this discussion. This is the way we're kind of pitching it. I'm not going to spend a lot of time talking about the marketing. We're coming up with the positioning framework, et cetera. But the idea is that this is strictly a deployment and management tool. We're going to have to wordsmith this and make sure it's like the final thing that appears in the box and the marketing materials, et cetera. But you guys shouldn't have to worry about that today. And then finally, I wanted to just talk about a couple issues. One is that we're going to require Windows 2000 Server. We use a lot of plumbing that's provided in the operating system. WMI specifically, you're going to hear a lot about that today. But we just couldn't make it work on NT4. We're going to recommend that you use Advanced Server or Data Center so that you get to take advantage of the work we're doing to make NLB, network load balancing, very, very easy to use. But it's not going to be required. We actually have, we know from most of our big customers that, Alteon, Cisco Local Director, and F5 Networks pretty much own this space today in large farms. And we want to make it, we want to be able to, help add value there and make it easier to manage the applications running on those. And in that case, we're going to support third-party load balancers, but we're not going to require that you use our own NLB stuff. So that's just a note on that. We want to make this thing completely complementary to existing management tools. So we have, there's another group at Microsoft called SMS, right? And they're good at like pushing Office out to thousands of desktops. And there's experts in here like BMC and NetIQ. You guys are all in here. And you guys are very good at managing much larger systems, right? Cross-operating system, cross-products, cross-everything, right? We have no interest in like sort of like growing up to be like a complete enterprise management framework. All we want to do is make easy, we want to enable scale out on the web and the component tier. And so what that means is that we've got APIs that we want to expose to you guys. We're totally WMI compliant. We consume WMI event data. We cough WMI events up, right? When we gather our data, we put it in a common schema. We're going to tell you about the APIs we use. We have a database that collects all the performance in the event, the log data in one spot. And we want to expose that to you so you guys can sort of like very tightly integrate that. I don't know what we're going to do in terms of co-marketing or a formal partnership. As a marketing guy, I'm interested in that, but we can talk about that later with your strategic alliance guys. Beta availability, we're cranking hard. Quentin needs to get out of here so we can go work on getting the beta out the door. But we want to make sure the beta is available in the first half of this year. In terms of target RTM date, we haven't committed publicly. Internally, our goal is to have it out by late summer or early fall. But the way we handle, for Microsoft's enterprise targeted products these days, like Windows 2000 Server, et cetera, we no longer gun for RTM dates just to hit RTM dates. We have a target RTM date, and we have ship criteria that we have to meet. So core partners need to sign off on it. Microsoft.com has got to have it in production, et cetera. And we won't ship until we hit our key metrics in terms of quality and adoption and sign off by our core partners. And so target date, late summer, early fall. But again, that's going to be dependent on how well the development process goes. Again, pricing and licensing yet to be determined. We're going to be figuring that out over the next couple of months, but not something most of you guys in this room need to worry about. And so without further ado, I'm going to bring Bob up, and he's going to show you a quick demo of Application Center 2000.